This is Lab 8, Investigation 2, Capacitors in Series and Parallel. Capacitors come in lots of different sizes and shapes and also have a very large range of possible capacitances. Most capacitors are pretty small in size and in capacitance. These are the ones we'll be using today. These are roughly a tenth of a microfarad. This one right up here is a 1 microfarad. This one right here is 25,000 microfarad, so it has a capacitance that's 25,000 times larger than that one. But even that, if you convert that to millifarads, this would be 0.025, this would be 25 millifarads. So 25,000 micro is the same as 25 millifarad, which would be the same as 0.025 farad. So a farad is a huge unit of capacitance. And this right here is a 1 farad capacitor. So it can store, or for a 1 volt across the terminals there, connected to two different pieces of metal that are isolated, if I put 1 volt potential difference across it, there would be 1 coulomb of charge separated. For this one, there would be 0.025 coulombs of charge, so 40 times less amount of charge separated from the piece of metal attached to this terminal from the piece of metal attached to that one. And these, of course, even smaller and even smaller. So if I put 1 volt of potential difference across there, there's a tiny amount of charge that's separated, and just looking at it, it looks like it's one solid thing, but inside of here you have a piece of metal that's insulated from another piece of metal. Or that's a way that you can imagine it, you can envision it, that we were at when we had the 2 pieces of aluminum foil. I want you to pause now and make your prediction 2-1 on page 155. Fill out this prediction and then we'll move on. This yellow capacitor will be C1, this red one will be C2. They're both about a tenth of a microfarad. I'm going to use this more sensitive device. It's not a multimeter, it just measures one thing. It measures capacitance, and you can see the dial goes from 200 picofarad to 2 microfarad, as much as 20 millifarad. So it would not be able to measure the capacitance of those because they're too large. This has a maximum of 20 microfarad. And that one's 25,000 microfarad. So I'm going to set this one, since we're expecting about a tenth of a microfarad, I'm going to set this limit to 2 microfarad, and I'll attach the leads to our capacitor. C1 first. C1 is attached, and we have, this is our reading, how many microfarads. So you can use that symbol that it looks like a cursive U. It's the Greek letter mu for micro. It's the same that's in our textbook. So you can write down 0.093 microfarad. Let's do capacitor 2. Capacitor 2 is now attached, and we have a reading of 0.089 microfarad. Now, for comparison, I put these capacitors into here, and I got a reading for the first one. Instead of 0.093, I got 0.095. So that shows you that they're within, the difference between 93 and 95 is roughly 2%. So when we use this for the aluminum foil, you can be fairly confident of those results. I'm using now a breadboard to connect these. I've got one of their legs in the same row, and that row connects those together, row 1. And then I've got the other leg in row 4, and so those are connected by the piece of metal that goes through that row underneath. So I just need to attach the multimeter to measure the capacitance meter to measure the capacitance. Okay, if you've not made a prediction, pause it now, make your prediction. What will it be when they are both connected in parallel? Our answer is 0.182 microfarad. Before we do step 3, I want to ask you to pause the video and answer questions 2.1 and 2.2 and make prediction 2.2. So we're going to connect these differently now. Instead of having them in parallel, I have one leg of this capacitor connected to the other leg of that one. They're all both in row 4. And I'm going to measure the capacitance now of these in series with each other. Pause the video, answer question 2.1, 2.2, and make prediction 2.2. I've attached the measuring device, and our reading is 0.044 microfarad.